All right, hello there. I'm going to do a quick recap of 8.6. I feel like as a class you understand it very well. I just want to give you just some resources in case you're going back to study or understand this better. So I'm not going to do the whole pack, and I'm going to pick and choose the problems I want to do. So the first example I'd like to look at is example 2. And this falls on the easy side, where you're basically given, in this case, you're given a vertex and an additional point. They're asking you to come up with an equation of the parabola that models this path. As you can see, the parabola is tracing out a path. It's a human cannonball person being shot out of a cannonball and landing in a net somewhere over here. So because they give you information about the vertex, we're going to use vertex form, which I think you all remember. Looks like this. And within the problem, I'm going to highlight in yellow, they give you the vertex and they give you an additional point. So they're giving you an h and a k, the vertex, and they're giving you an x and a y in that additional point. So what I'm going to do is I'm going to take, maybe I should write that out. This is my x and y. This is my h and k. So let's go back into the equation and put in those numbers. It's going to leave just the a exposed, and we're going to find the a. We're going to solve for it. So my y, just going in order, my y from the problem is 15. My x is 0. My h, the x coordinate of the vertex, is 50. And my k, the y coordinate of the vertex, is 35. So let's put in all the things from the problem. We'll solve for a. I'm going to do this rather quickly because you don't want to watch me do math, right? This is negative 50 squared, which is 2,500. So a is negative 20 over 2,500. If you cancel out the trailing zeros and reduce the remaining fraction, you get negative 1 over 125. So my equation is y equals negative 1 over 125, x minus h, which is 50, squared plus k. And that's it. And I think the follow-up usually is a question, well, now that you've got the model for this particular thing, what can we infer? What other information could we get from the problem? So in part B, the performer lands in a net 90 feet from the cannon. Well, notice that 90 feet represents the horizontal distance, and that in this problem, the horizontal distance from the launching point is basically just our x value here. So I'm going to take my x value, which is 90, and plug it into my new equation. Y equals negative 1 over 125, 90, whoops, hang on a second. 90 minus 50 squared plus 35. I realized I don't have a calculator next to me. So 40 squared is 1,600. I may have to rely on you to do this. I can run and grab my phone really quick, but I think for now, this is going to be negative 1,600 over 125. 1,250 would be 10. 1,500 would be 12. 12.8. This is negative 12.8 plus 35. Who needs a calculator, right? So the performer is 22.2 feet above the ground. And if you look at the graph, that looks pretty solid. That's basically just above 20. So you can see it checks out. All right. Example 3 is very similar, but the given information now is not the vertex. If you look at the graph or read the information, they're actually giving you not the vertex, but they're giving you the intercepts. So therefore, I'm going to use intercept form. A, x minus r1, x minus r2. So what do we know? Well, we know that our two intercepts are 4 and 24, and they give us the additional point of 9.6 for my x and my y. So I'll do like I did before. This is R1, this is R2, there's x and there's y. Again, we have all the inputs. We just have to solve for a and drop it back in. So again, going in order from left to right, the y value is 9.6. We're solving for a. X is 0. The first root is 4. The second root is 24. So 9.6 equals a times, that's -4 times -24, that's 96. A is 9.6 over 96, and I know that that's 1/10. So now that I know a, I can say y equals 1/10 x minus 4, x minus 24. It's a little unsatisfying. We should write that in standard form. Anything I give you for an assessment, I'll ask you to put it in standard form. You don't have to remember that. But you never know, your teacher next year may not want that to be the case, or it may be different. So every teacher is different in what they want. But they're doing it for they want you just to be as well prepared as possible for whatever it is you're presenting. I think some of those fractions are going to cancel. Let me erase those. 28 over 10 is 14 over 5. 96 over 10, well, they're both even, so 48 over 5. You guys will probably find a math mistake or two. I'm not really rushing, but I think I am rushing a little bit. Part B talks about the average rate of change. I don't want to do that now. It's really just the slope. If you're interested in doing that, I don't remember if we talked about it. I think we did. The average rate of change is f of b minus f of a over b minus a. And in this case, it's over the interval where it's decreasing. Well, let me take my highlighter out. Where is it decreasing? From 0 to the vertex. Oh, where's the vertex? If you remember, we said the vertex is halfway between the two zeros. So h equals 4 plus 24 over 2. That's 14. So, A would be 0 and B would be 14. This is not a likely quiz question, but I wanted to just begin it for those of you that had the curiosity to look at it. You're just finding the slope. What you're really finding is you're just finding this linear. We're pretending this was a line, and you're finding the actual slope, even though along that curve, the slope is changing as you move along. And we're basically linearizing that. I feel like I just lost a few people with that crazy explanation. I'm going to move on. Number 4, I am not interested in. Number 5, we did in class. But I think all these we did in class. I'm just redoing them for you. So these kind of problems in example 5, it's the kind of situation where, and I don't want to get too specific with these and bog you down with details, but typically you have a fixed amount of fencing. And depending on the length x that you choose for your width of the fence, you could have something like this that has a relatively large area, but you could be silly and you could do like make x be really small, meaning you'd have more fence available to make the fence longer. And you can, I don't know if I made this clear, but this area is different from this area. I think it's smaller. I really don't know. It doesn't really matter. But the point is, depending on the value of x that you choose, the area could be bigger or smaller. So anyway, don't really worry about that. Just go by the equation that they give you, right? Anyway, depending on the value of x, the area is negative 3x squared plus 60x. Well, this is just a parabola. It's a downwards opening parabola because a is negative. And remember that whenever they talk about a maximum or a minimum, you're going to be looking at the vertex. Here's a downwards opening parabola. I want to focus on the vertex. Well, this vertex, this quadratic is in standard form. So I can get the vertex by saying h is negative b over 2a. And I think that's negative 60 over 6 negative 6, which is 10. And then K is just the area formula evaluated at that number. And that is going to be, don't make me write it out, it's 300. You can do that on your own and figure out when you plug in 10 into that area formula, it's 300. So I just answered both questions at once. What width would give the maximum area? 10. When the width is 10, this area is maximized. Oh, and what is that maximum area? When I plugged it into the area formula, I got 300. So that's both. And I should put proper labels on those. 10 feet and 300 feet squared. All right, and then the last topic we covered, this one's actually really important because these things will all kind of remain with you throughout your math studies. I think this one is a big one because it comes up in physics, it comes up in calculus. So I just think it's a good thing to know how to do. The generic formula that you want to know is this one here. But when you're dealing with, and by the way, this formula governs things that are in what we call free fall. Now, free fall doesn't mean like you're falling from the sky. I mean, it could mean that. But it means like when you throw a baseball to a friend or a football to a friend, or you hit a golf ball, or you launch a rocket, or you're feeling silly and you throw a stone off of a cliff into the water to watch it splash. Those objects are considered in free fall because you can't throw it hard enough that it will never come down. So eventually what happens is you throw the thing up in the air and the force of gravity eventually slows it down and then makes it go into free fall. So this formula I've highlighted in purple is the generic formula, but whenever we're here on Earth, which is where most of our studies will take place, it turns out that the actual constant that is assigned to the Earth, I mean, just because of the way the Earth is formed, the gravitational constant is the acceleration due to gravity is negative 32 feet per second, and that goes in for G. So when I plug that in for G here, negative 1/2 times negative 32, I get negative 16. So this formula applies to any object in free fall on the Earth. And essentially, these two numbers are just drop-ins. You find them from the context of the problem, and you've got yourself a formula that works for that particular situation. Okay, so we'll read this problem out loud real quick. Lee stands on the edge of a building at a height of 60 feet. I didn't really say before. We did talk about it in class. Let me erase these, and let me go slower and say that V sub 0 is the initial velocity, right? You throw something up in the air at 30 feet per second, that's your initial velocity. And then H sub 0 is the initial height. Where did you throw it from? Were you throwing it off a 200-foot cliff? Well, then your initial height is 200. Were you launching it from ground level? Well, then your initial height was 0. Did you kick a football from 2 feet in the air because that's how high your foot was when you kicked it? Your initial height was 2 feet. Okay, so that's kind of the basic idea. Initial height. So you look for those clues in the problem, you make an equation out of it, and then you answer it based on the clues in the problem. Do they want to know where the maximum is? Find the vertex. Do they want to know when it hits the ground? Set the height equal to 0, and you've got yourself a fairly easy problem to do because you guys are very good at like solving the equations, and that's really the important thing. So let's take a look at this situation here. I've already read the problem. It says write a function to model the equation. So here's kind of my blank equation with nothing filled in, just taken from above. And what is my initial height? Well, Lee is standing at the edge of a building at a height of 60 feet. So 60 will be my initial height. Made a little mistake there. 60 is my initial height. And I'm assuming Lee is a boy. Lee throws the ball upward with an initial velocity. He throws it at 68 feet per second. That's my initial velocity. And there we go. This is my height equation specific to this situation that's being described in the problem. All right, so there you go. Part A done. What is the maximum height of the ball? Well, it's a downwards opening parabola. Here is basically the flight of the ball. I want to know what's the maximum height. When did it happen? We're going to answer those in reverse because the when did it happen is like your x value. The time is like the x value. It's the independent variable. And the height is the dependent variable. It's basically like the y coordinate here. So we can find our x coordinate of the vertex by doing negative b over 2a. I'm definitely going to need a calculator for this one, I think. Let's see what happens. All right, so h is negative 68 over 32, both divisible by 4. Wait, something's wrong here. It's negative 32. So I get 17 over 8. I know that that's 2.125. My k value is the height at 2.125. And if I plug that in, I can't do that. I'm going to put you on hold. I can't pause it because I'm recording my screen. I'll take you with me while I grab my phone. Hang on. Going to the other room. You would think as a math teacher I'd have a calculator in my house. I actually do. I don't know where it is. All right, so I'm going, got my phone, pulling up the calculator, and I'm going to start typing as I walk back. So 16. All right. All right, I'm sitting down. Here we go. All right. Negative 16. Parentheses. 2.125, close parentheses, squared. So I already made a mistake. 2.125. Close parentheses, squared. Plus minus. Oh boy, I got to start this over. You're probably going to want to fast forward this part of the video. Negative 16 times 2.125 squared. All right, got it. Plus 68 times 2.125 plus 60. Yeah, I remember that answer from class. You get 132. Whoops. 0.25. 132.25. So, answer them in reverse. What's the maximum height? It's 132.25. When does it happen? After 2.125 seconds. Sorry for the delay there. I should have had my phone with me the whole time. Part C, last part. How long will it take the ball to land on the ground after being thrown? Well, what's the height of the ball when it hits the ground? It's 0. So I'm going to take this equation and just set it equal to 0, because that's what I want the height to be. Everything here is divisible by 4, and I want the leading coefficient to be negative. I'm going to divide by negative 4, so I get minus 17t minus 15. Oh boy, I factored this in class. I think it was t minus 5. Let's factor it together in case you forgot how to factor. All right, let's do it together. We need two numbers that multiply to AC. They need to multiply to negative 60. They need to add to B, which is negative 17. Those numbers are negative 20 and 3. So I split up my negative 20t into negative 20 and 3. So let's do common factor of the front pair of terms and common factor of the back pair of terms. And we get, I'm going to go over here, t minus 5 and 4t plus 3. You could also solve this by quadratic formula. Not bad. Or completing the square is kind of a hassle for this one, but you can choose how you want to solve these problems. If you set each factor equal to 0, you get 5 and negative 3/4 for t. Well, we're not interested in time that's negative. We don't want to know what happened before we ran the experiment. So there's my time when it hits the ground is 5 seconds. All right, now there's some practice problems here. I think I'm going to stop the lesson. Let me just see if there's anything in the lesson that is like considered different. Like number 1, I did in the notes that I just gave. Number 2, I did the same thing. 3 is not relevant for us right now. Number 4, no. Number 5, we'll do number 5. Maybe number 6. 7 is a repeat of like number 1 from the notes. Now, they're all pretty good questions, but I'm gonna do number 5 and maybe number 8. And I'll end the video. All right. Number 5, we have a cafe that currently has a patio whose dimensions are 25 by 15. Let me do that a little bigger, by the way. The current dimensions of the patio are 25 by 15. Oh, by the way, that area currently, I don't know if it's important, but that area is 375 square feet. Now, what the owner wants to do is she wants to add 329 square feet by expanding the existing patio. Now, you can do this in a number of ways. I'm going to settle on the easiest way after talking to some students in class and the way they did it and the way I did it. I think the easiest way to think about it is to say that she wants to expand. Let's just expand it in this direction, like this. All right. So in doing so, she wants to add 329 square feet of area to the existing patio. So in total, we're going to have, what is 329 plus 375? I think that's 704. And the question in my mind is, well, we expanded the patio by X units this direction and X units in this direction, according to the problem, right? She wants to add X units to the length and X units to the width, right? That's what we did here. I should have been more specific about that while I was doing it, but basically we're expanding this side of the rectangle by X units, this side of the rectangle by X units. So now looking at the larger entire black rectangle, let me draw a kind of like, let's highlight it. Looking at this rectangle, we know it has an area of 704, but what are the dimensions that make it up? Well, the red rectangle used to be 25, but we've added X units of length to it. And the other dimension used to be 15, but now we've added X units of length to it. When I did this in class, I did it with 2 X's, one on either side, and you just end up getting half the value. So that's why I think this method is easier. Anyway, if we multiply this out and solve for X, you'll see what happens. Here we get, foiling it out, 375 plus 40x plus x squared, if I'm not mistaken, equals 704. I'm going to put the left side in standard form, and I'm going to subtract over the 704 in the same step. That should be minus 329. All right, and just to speed things along, this is leading coefficient is 1. So I can do the simple type of factoring. If I know 2 numbers that multiply to negative 329 and which add to 40, right? We don't need to do complicated factoring. We don't need to do grouping. We can just do simple sum and product. I happen to know from doing the problem a couple of times that 47 times 7 is 329. And if I want them to add to 40, I can make the 7 negative. So I get x plus 47, x minus 7 is 0. So I could have added negative 47 units of length. That doesn't make sense. Or I could have added 7 units of length. So by what distance should the patio be extended? 7 feet. Okay, and that's the final answer there. All right, the last one I'm going to do, anything else you want to do, we can talk about during class or during period 9. We'll do number 8, which is a 3-part question. It's about 2 rock climbers They try an experiment while scaling a steep rock face. They each carry rocks of similar size and blah, 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 and shape, similar size and shape up a rock face. One climbs to a point 400 feet above the ground, and the other climbs to a place below at 300 feet above the ground. The higher climber drops the rock, and 1 second later, the lower climber drops their rock. Let's write two functions that can be used to model the height of each rock. I'm using my own words here. H1 is the height of the rock dropped by the higher climber. So they are at their height function is, let's go back to this general equation. Right, we're using this one, right? This equation right here, negative 16t squared. Now they dropped the rock, so the velocity is 0, and the initial height is 400. So I'm going to say in number 8 that their height equation for their rock is negative 16t squared plus 400. Whereas the second person, they're also negative 16t squared. Their velocity is also 0 because they're dropping their rock. Oh, I did make a small mistake here. Let me go back 1 second. It's not t squared. It's t minus 1 squared because they're a second behind. They drop their rock 1 second later, right? So it's not t squared, it's t minus 1. So when H1, when their rock has been dropping for 4 seconds, the second person has been dropping for 3 seconds. They're a second behind, so t minus 1. And their starting point is 300. Both climbers, they're dropping their rocks from rest. They're not throwing them. So the initial velocity is 300. So there's our functions. And then number 2, assuming they fall to the ground without hitting anything on the way, which will reach the ground first, we're going to set each one equal to 0 in order to make that happen. I'm going to subtract 400. We're going to divide by negative 16. And t in this case can only be 5. I mean, technically it's plus or minus 5, but we don't care about the negative value. So the first climber, their rock hits the ground after 5 seconds. All right, as far as number 2 goes, we'll set that one equal to 0. I'll subtract 300. I will divide by 16 or negative 16. I'm going to take the square root right now. Again, I did this before. I think it was a different problem in class. I like the fact that 16 is a perfect square, so I'm just going to say radical 300 over 4 equals t minus 1. I didn't do plus or minus. Again, I'm ignoring the negative value. And by the way, 300 is 10 radical 3. I don't want to go crazy with the simplifying because I'm just going to be typing it into a calculator. You don't really have to simplify. If your final answer relies on you typing into a calculator. So in fact, let me go backwards and just let me not simplify it, right? Because I'm punching this into a calculator. T is going to be 1 plus radical 300 over 4. So let me do that real quick while I've got you here. 300 square root, enter, divided by 4, enter, plus 1, enter. I'm getting 5.33 for the second climber's rock to hit the ground. So who hits the ground first? Clearly, climber 1 takes 5 seconds to hit the ground. All right, and then part C I'll do in a different color because I've kind of bled into the space. When will the rocks be at the same height? We'll just set these equations equal. Now, depending on what class you're in, one class we didn't do this problem at all. We're going to do it tomorrow. The other class, I just said do it on a calculator, but since I've got the time here in the video, I'm going to actually do it. I think the best thing to do is to expand negative 16 t squared minus 2t plus 1 plus 300. So I get negative 16 t squared plus 400 equals negative 16 t squared. Those are going to cancel. That's nice. Plus 32t minus 16 plus 300 is going to be 284. So look, these cancel. And I could bring 284 over to the left side. I can subtract it. And I'm going to get 186, 186, yikes, 116 equals 32t. It doesn't quite go in 4 times, but it's 116 over 32. They're both divisible by 4. That's 29 over 8, which is 3.625 seconds when they'll be at the same height. All right, so just a quick kind of refresher. I tried to hit one of every major type of problem. The overall theme of this is just feeling comfortable with setting up the equation, knowing what they're asking for, and doing that. So I know that I have 50 Algebra 1 students. I know you're all capable of doing this. So just kind of take your time, take a deep breath, be confident in yourself. I know you can do it. So if you have any questions, please ask in class next time I see you, or stop in during period 9. All right, I'm going to end the video, and I'll talk to you all very soon.